Okay, so our first task, find the values of x where f of x has a horizontal tangent line if f of x is equal to x cubed plus 3x squared minus 1. Well, back in algebra class, you talked about horizontal lines. Here's an example of one. We've got ourselves the coordinate plane. X-axis is the solid horizontal line, y-axis is the solid vertical line, and right here is the broken line of y equals -2. Well, what's the slope of this line, y equals -2? Or in fact, what's the slope of any horizontal line? Yeah, you guessed it. The slope is 0. All horizontal lines have a slope of 0. Well, we want to find the horizontal tangent line. From the derivative song that you've just memorized, the derivative is the slope of the tangent. So if we get the derivative, we have the ability to find the slope of the tangent line. And we want the slope to be 0. So to find a horizontal tangent line, we are truly looking for when the function's derivative is equal to 0. So we need to start by getting the function's derivative. Now I want you to use the rules that you've already learned. So take a second and find the value or the formula for the derivative of f. Okay, you probably wrote down 3x squared plus 6x. And if you did, that would be correct. Now we're interested in a horizontal tangent line. Horizontal lines have the slope of 0. So we're really interested, when does this derivative equal 0? And presto, you're back in algebra class. We need to find the values of x where this function is equal to 0. Well, it's a quadratic, and both of the terms have an x. So I'm guessing that you're thinking right now, it's time to factor at least that x out. Now we could certainly factor out a 3x. We don't have to, but we do have to definitely factor out an x. And 3x squared divided by 3x leaves us with x. The plus sign drops down. 6x divided by 3x is 2. So we now have a product which is equal to 0. And we like that very much. Because when you have a product that's equal to 0, you know that either the first part must be 0 or the second part must be 0. So if we cover these two items up one at a time, we can solve for the zeros of our derivative. If we cover up the x plus 2, we see that 3x is equal to 0. If 3x is equal to 0, what does x have to equal? You got it. X must be equal to 0. That's one of our answers. But we also have to cover up the first part. If we cover up 3x, then we have x plus 2 is equal to 0. What value of x makes that true? That's right. X can also be -2. And we're done. We have found the two values of x where the function has a horizontal tangent line. And we know it's true because these two values of x cause the derivative of the function to be equal to 0.